both problems that involve two variables and more than two variables. Are you communicating? It can be used for variables that involve two unknowns or more than two unknowns. So for the purpose of the example in the class, I'm going to use the last example to solve a simplex method. If you are looking, for example, for three variables, consult your textbook, and it's available on page 59. For those of you that have gotten the textbook, go to page 59. There's one example there about two example, and there's a question here. So you can practice that question before the exam day. That's there. So you tell me the question that we have discussed last time. Is it maximization problem or minimization? So you maximize what? Yeah? 3x1 plus 4x2. Subject to what? What are the constraints? Material constraint number one. What is it? 4x1 2x2. These are equal to what? These are equal to, and this is what? Machine constraint. Who has the red marker? I'm the first. This machine constraint. And next constraint is what? Labor constraint. That is what? 4x1 plus 6x2 180. Labor B. The next constraint is what? x1 plus what? Less than equal to what? 40. That is what? Material constraint. The next one is what? Trade agreement. X1 20. X is what? 10. Okay. So the other constraint that will not be given to you in your is what? X1 is what? Greater than equal to 0 and x2 greater than equal to 0. Now, these are the rules that guide simplex method. First, we state the objective function and the constraint. Okay? The second one is to convert this inequality to equality and add what? Slack variables. There is what we call slack variables. You will know the roles that these slack variables are going to play when we get here. That's slack variable. You add slack variable to the constraint. After adding slack variable to the constraint, you construct the first simplest table. So when you are done with the first simplest table, you choose from the Z row. The Z row consists of the objective function. You choose from the Z row the highest value here. And look at the column that corresponds to that value. Divide the solution variable that column and pick the one that gives the minimum value, if not 0, and the one that has negative sign. When you are done with your first initial simplest table, the Z row consists of the objective function. You choose the value that is the highest first. You look at the column that corresponds to that value. Divide the solution column by that column. What the answer that gives you the minimum is what is going to be your 5 volt element. 5 volt element. That 5 volt element, your duty is to make that 5 volt element equal to 1 by mathematical manipulation. Then every other value on that column, you make it equal to what? 0 by mathematical manipulation, which we are going to do now. Then after you are done with that one, you go to the next value on the Z row that is the maximum, the highest. You pick that one also. You look at the column that corresponds to that value. You divide the solution variable by that column. And make your private element equal to what? 1. And every other one on that column equal to what? 0. You continue like that until all the value on the Z row, which consists of maximum, becomes what? 0 or negative. That is where you will stop. Then you look at your solution variable and pick from there and see what you give it as the solution quantity. That will be the maximum value or the maximum contribution that that particular product will give to the manufacturer at optimum point. So we are going to do that now. So the first thing is to change this to what? To equality sign and add what? Slack variables. Now to add your slack variables, you know the highest S here is S2. So if you want to add the slack variable, the next one will be S3 to this one. The next one will be S4, S5, X6 and X7. So let's go. To add the solution, the slack variable for the constraint. Remember, it's only the constraint that are going to add the slack variables, not the objective function. So for the constraint, the first constraint is going to x1 plus x plus x3 equals to what? 100. You have added the slack variable s3. The next one is the next constraint here. 4 x1 plus what? 6x plus x4 equals to what? 18. You have added another slack variable. You go to the next one, constraint. x1 plus x2 plus x5 is equals to what? 40. Are you communicating? Then the next constraint is what? x1 plus x6 is equal to what? 20. Then the last one here is what? x2 plus x7 is equal to 10. You have added the slack variable and you have converted it to what? The equality sign. So the next thing you are going to do is to set up your first simplex table. Set up your first simplex table using this objective function and this constraint which you have added the slack variable. So this is how your table is going to look like. So how many slack variables do you have? How many? 1, 2, 3, 4. That's 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. So this is the solution quantity. This is your slack variable. This is your product. The product is S1 and what? S2. And this is the solution variable. Now, in this solution variable, so here will be x3, x4, x5, x6, and x7. Now, this is your slack variable. You are going to bring them here first on the initial simplex table. You have to bring all the slack variables here on your solution variable. Bring everything here. So you are going to have what? x3, x4, x5, x6, and x7. Then you now bring your objective function, of which I will call it z. You can name it anyhow you want it, but I will call it z. So you draw your line. Okay. Now, what I'm going to put here, you start from the constraint, because this one represents your objective. The coefficient of this is what I'm going to put here. The coefficient of x1 for the first constraint. The coefficient of x1 is what? 4. The coefficient of x2 is what? x3 is what? Do you have x4 here? Do you have x4 here? 0. Do you have x5? 0. Where x is 0. S7 4. Then equal to what? Who is that there? Who is not there? Let's go to the next one. Okay, then we have to do the next one. Go to the next one. Next one screen. The x1 is what? 4. x2 is what? 6. x3. Where is x3? 0. x4. x5. x6. x7. Equal to what? Then you go to the next one. x1, x2, x3, x4, x5, x6. Then what? Then this one, x1, x2, x3, x4, x5, x6, x7. Equal to what? Then the last one here, x1, x2, 0, x10. Then you come to z, which is what? Your objective function. The x1 is what? x2, x5, x6, 0, 0, 0. Equal to what? Equal to what? 0. And nothing less, so this is 0. So this is your first simplex table. This is the first one. Now, your duty is to make sure that everything here will be either negative or minus, or negative sign, or either negative or equal to what? 0. That is when you will stop. This is Z column, I mean 0. Everything here has to be 0 or negative. That is the point we are going to stop. So how I'm going to do it is where we are going now. Now, the first thing you are going to do after your first simplex table is to look at this Z rule. Which value is the highest here? Which value is the highest in the Z rule? 4. Now, this 4 now. Is under which column? That means you are going to divide this solution quantity by the column in the x. Don't hold anything with 0. That means everything here up to this point. Divide by. So the first one will be 100 divided by what? 2. Is equal to what? 50. Second one is 180 divided by what? 6. Is equal to what? 30. Next one is 40 divided by 1. 40. The next one is 20 divided by 0, which is equal to what? 0. So I said ignore 0 value or negative value. So out of these three now, which one is the lowest?
30.
Huh?
30.
30?
10 divided by 1.
Oh, sorry. 10 divided by 1 is equal to 10. So out of 50, 30, 40, and 10, which one is the lowest?
10.
10. And which one will give us 10? Which answer give us 10? Which answer corresponds to what? And you know that we are dealing with this here. So we are dealing with 4. This is where we started from. And this is the one that gives us what? The lowest value. That means our 1 here is the 5-volt element. 1 is the 5-volt element. Because this is the one that gives us the minimum after we have done the division. And we started from here. Meaning that this particular one is the one that is the 5-volt element. So our 1 is the 5-volt element. So now when I was explaining, I said you have to make the 5-volt element equal to 1. And every other value here is equal to what? 0. Now it's already equal to 1. So you not do anything. Assuming it is not equal to 0. Huh? This is now 20 over 0. zero now, and I say it is not zero or anything that is negative. Okay? So I said your duty is first here is to make this famous element equal to 1 before you go on. Since it is equal to 1, we will not do anything here. But assuming it is not equal to 1, assuming it is equal to 3, what can you do to 3 to be equal to 1 mathematically? If I divide 3 by 3, it will be equal to 1. Meaning that we are going to divide 3 by everything here. Because whatever happens to this one must affect everything here. So assuming this one is 3, I want to say 3 divided by 0, 3 divided by 3, and this one automatically gives me 1. 3 divided by 3, 3 divided by 3, and 3 divided by this. Get 1. If it is 4, divide 4 by 4 to give you 1, and you have to do it for everything on this board. Are we communicating? So since it's equal to 1, we will not do that one. We move to the next one. Let's do it. Yes? Want to snap? So where is the now you need to readjust this arrangement because we said we will make everything here equal to 0 and only this one will be what? 1. We make everything on this column equal to 0. Only perfect element will be equal to 1. How do we do that? The first one is to do to subtract this. Don't forget. Sorry, the next thing you are going to do after you apply your private element, this S2 to change this S7 to S2 is under S3. So you change this S7 to S2. The same way you are going to be doing it. You come here, under which you get your private element, you change that system variable to what? To this particular one. So if you have S2, S2. So this one now, in our next simplex table, this one will not be S7 again, to be S2. Are you communicating? Now, we have to subtract this column from this column. We subtract this column from this column, this column from this column, this column from this column, and so on. Yes, from this column that gives us the private element. Subtract all this column from this one, including this. Yes. Now, the first one, is S3, right? So the value of the S3, 4, 2, 1, 0, 0. How many zeros? 4. Then 100. So now come here. Now, don't forget that your duty here is to make this one equal to what? 0. And if you are subtracting, you have 1 here, you have 2 here. How can you subtract 2 from 1? How can you give me 0? What manipulation can you do to make sure that when you subtract this from this, it's going to give you 0? Who can help? Since this one is 2, you can easily say this 2 multiplied by everything here. By the time you do the minus, it will be 2 here. So the 2 times 1 will be 2. 2 minus 2 will give you what? 0. So the next thing that is going to be here is minus 2x1. So x2. This one is already 2. This one is already 2. So minus 2x2. So everything here will be x2. So multiply minus 2 by everything that is here. So this one will be 0 and this one will be what? Minus 2. Next one will be what? 0. Next one will be what? 0, 0, then minus 2, 0. What is the solution here? 10 and 2. That is minus 20. I say our duty is to make everything here, never except this one that will be equal to 1. And I said I have to minus this from this. If if I said 2 minus 1 is equal to 1, you are not giving me 0 now. Eh? What can I do? So that when I minus this from this, I'm going to get 0. And I say I can just do it by multiply 2 by everything here. I cannot do it for only this one. I have to do whatever I affect this one, I affect everything on this one. When you say 2 times 2, this one will give me 2. So 2 minus 2 will give me what? 0. That's why I multiply this 2 by everything here. So that by the time I do the math, this one will give me 0. Which one? This one? This one? Here. 2 and this. And this. And this. Okay, this I can okay. This is the last one is the one that I can okay. Now, wait, now come this one now be your new XT. Or if you say 2, you know that and now I've already put the minus. So what you are going to just say 4 minus 2 minus not minus 3. But if that is what I'm going to make you understand, you can just say 2. This one will be 4 minus this, 2 minus this, or whatever.